New World Order Decision Time with NATURENETSCHOOL. Pictures used in this document are not of characters described in messages below them. Kindly bear with me in case of any inconvenience. Relevant academic programs to invoke creative and innovative ideas. Physics and industrialization. Concepts needed to operate or manage industrial hardware require reasonable understanding of physics concepts learned in schools. Make physics more practical and research-oriented. This will boost industrialization. Part of physics syllabus used in Kenya at Form 1 level includes measurements, contents, definition, estimation of quantities, conversion of units, measuring instruments. Some statements of objectives in the syllabus can be reorganized to make them more practical and research-oriented, as quoted here. Specific objectives. By the end of this topic, the learner should be able to define length, area, volume, mass, density, time and state corresponding symbols and SI units. Convert other metric units to SI units. Estimate length, mass and time. Use accurately the following measuring instruments: meter rule, tape measure, beam balance, stopwatch and clock, measuring cylinder, pipette, burette. Determine experimentally densities of different substances. Solve numerical problems on density. Solve numerical problems in measurements. Definition of terms can be acquired through improved interaction with objects during practical activities. They should understand meanings and sources of definition of terms from recommended texts and from other relevant sources of knowledge too. Verification of Hooke's law. Challenge them to discuss results of experiments, to research for meanings and sources of definition of terms from all relevant sources before writing reports. Challenge them to discuss their experimental results in groups before writing reports about the outcome. This can broaden their knowledge. Challenge them to use measuring instruments practically in real time. Test this in details at Form 1 level. Form 1s can be challenged to design simple measuring instruments. Reduce wordy physics tests. Very wordy physics statements do not test science alone, but ability of children to understand language used as well. Challenge them to identify other sources of knowledge similar to the ones expressed in their measurements course books. Challenge them to compare and contrast definitions of terms obtained from different sources of topic, measurements 1. Ensure that they use measuring instruments correctly. Test this in real time. Challenge them to make their own basic measuring instruments from locally available materials. This can develop designers from grassroots. To make simple measuring instruments to broaden their knowledge. Children can make meter rules from polished timber or plastic. Simple tape measure from strips of plain papers or polythene. And simple beam balance from timber or plastic. This can promote creativity and innovation from grassroots. Challenge them to compare instruments they make with standardized ones. Let them determine densities of substance in real time. Challenge them to develop and solve numerical problems from their experiments and projects. They can develop various practical projects on measurements. Topic: forces. Practical objectives. By the end of the topic, the learner should Identify other sources of knowledge on forces. Distinguish different types of forces experimentally and state correct SI unit. Demonstrate effects of forces. Demonstrate the difference between mass and weight. Determine mass and weight experimentally and mathematically too. Apply the formula correctly. Demonstrate that mass is a scalar while weight is a vector quantity. Link topic forces to topic measurements. Develop simple instruments that can measure forces as a project. Challenge them to identify other sources of knowledge on forces to promote research. Let them determine mass and weight mathematically as well. Challenge them to develop simple instruments and use them to measure forces. Topic: pressure. Practical objectives. By the end of the topic, the learner should be able to identify other sources of knowledge on pressure, perform experiments to demonstrate link between force, area, and pressure, perform experiments to determine pressure exerted by solids both experimentally and mathematically, perform experiments to demonstrate effects of depth and density of fluids on pressure. Apply the formula P is equal to sigma GH correctly. Identify correctly stated Pascal's principle of transmission on pressure. Compare and contrast any two or more different statements of Pascal's principle obtained from other sources of knowledge. Perform experiment to verify Pascal's principle. Identify various applications of pressure. Perform experiment or projects to demonstrate at least one application of pressure. Link topic pressure with topic force and measurements. Transmission of pressure. Challenge them to demonstrate links between measurements, force, and pressure to promote consistency in acquired knowledge. Atmospheric pressure. Challenge them to demonstrate applications of atmospheric pressure in real time. Challenge them to identify and describe various applications of Pascal's principle in real life. Correctly stated principle. Mere statements of Pascal's principle in words is insignificant compared to ability of a child to identify a correctly stated principle, among others. Physics practical rooms